So, welcome to the video lecture series on theory of computation. And this is Dr.K.N.Sivabalan, and in today's video lecture we will be learning about how to convert an NFA to DFA. So, the process of NFA to DFA conversion is a simple process. Now, this is the diagram which has been given here. So, in this diagram, we have to actually take this diagram into consideration and then convert that into a transition table. Now, the first step is we have to transform this diagram into a transition table. Now, how will you convert that into a table? So, how many states are here? There we have 3 states. So, Q1, Q2 and Q3. Okay. Q3 is a final state and Q1 is called as an initial state. Now, we have 2 inputs here, 0 and 1. So, 0 is the first input and 1 is the second input. Now, we will construct a table for this one, and this table is called as an NFA table. So, now in this table, now Q1 when 0 is applied, we go to Q2. So, we go to Q2. Now, in Q1 when 1 is applied, there is not any input called as 1 in Q1. So, we will just make it as pi. In Q2 when 0 is applied, we come to Q2 itself. In Q2 when 1 is applied, we make 2 major transitions. One is in Q2, another goes to Q3. So, we will just write it as Q2 and Q3. Now, in Q3 we do not have any transitions, so simply we will write it as pi. Now, the first step what we have to do is, in order to convert that to a DFA, so we will write here as DFA conversion. DFA conversion. The first thing what we have to do here is we take the first row of the NFA transition table into account. So, what is the first row here? The first row is we will have Q1 as the first row, we have 0 and 1 as an input now. Okay. So, first we will just try to fill the first row itself. Now, let us see in Q1 when 0 is applied, we go to Q2. So, we will write Q2 here. And now, in Q1 when 1 is applied, there is not any transition. Okay. But instead of transition, we have mentioned pi. So, pi no transition or pi is not permitted in DFA. So, we will substitute this phi trap state. Let us assume the trap state is called as QT. QT is called as a trap state. Now, we have 2 new states now. One is Q2 and QT here. So, what is Q2? Q2 we have to write it here. So, we will make an entry for Q2. Now, Q2 when 0 is applied. In Q2 when 0 is applied, we get Q2 itself. So, we will write Q2. In Q2 when 1 is applied, we get Q2, Q3. So, I will put a square brackets here. We will get Q2 and Q3. Square brackets again. Now we have another new state called as QT. So, I will just change this color. Now, I have another state called as Q2, QT here. QT is called as a trap state. So, QT does not have any transition now. So, what we will do is, we will actually substitute QT by QT itself. QT when 0 is applied, it goes to QT itself, and QT when 1 is applied, it goes to QT. Since it is a trap state, we are not concerned about that. Now, what is a new state we have got here? Now, earlier we have Q2 entry is there, then QT entry is there. Now, we have got a new state called as this one, called as Q2, Q3. Okay. So, we will make an entry for this Q2, Q3. So, put a square bracket here. Now, in Q2, Q3 when 0 is applied, what will be the output? So, we will write a transition here. So, delta of Q2, Q3 when 0 is applied. So, we will get delta of Q2, 0 union of delta of Q3, 0. In Q2 when 0 is applied, we get Q2 itself, and in Q3 when 0 is applied, we get pi. So now this will be equivalent to Q2 alone. Now when Q2, Q3 when 0 is applied, we get an answer called as Q2. Okay. Now we will go for the next one. In Q2, Q3 when 1 is applied, so what will be the output in this case? When in Q2, Q3 when 1 is applied, so delta of Q2 comma Q3, if 1 is applied, so we will give delta of Q2 comma 1 union of delta of Q3 comma 1. So Q2 comma 1 will be resulting in the answer called as Q2 Q3 union of, in Q3 when 1 is applied, it results in an answer called as pi. So you get the answer called as Q2 Q3. So now in Q2 Q3 when 1 is applied, we get Q2 comma Q3. Now we will check it out whether any new state is here. Now Q2 we already have an entry, and Q2 Q3 also we already have an entry. So there is no new states found here. So we will stop here. Now how will you identify the initial state and final state? Initial state is by default it is Q1. So Q1 here is an initial state, and then what is the final state here? So Q3 is called as a final state, but in DFA transition table we cannot find any Q3 in an autonomous manner. But what you have to do here is wherever Q3 is found, that will be considered as a final state. So we have 4 states in DFA. One is Q1, Q2, another is QT is called as a trap state, and fourth one is Q2, Q3. In Q2, Q3 we have Q3. So this is considered to be the final state. Now we will convert this into an equivalent diagram. So now how to convert this into an equivalent diagram? So I just make here I'll try to draw a diagram here. So from this table we have to draw a diagram. Okay. Now I will just use some other color now. Pen and okay. So okay. Now how to draw a diagram for this? So I have how many states here? I have 4 states here. So Q1, another is Q2, the third is, I'll just write it here as QT. QT is called as a trap state, and fourth is Q2, Q3. So that is going to be the final state. So I have a final state here. Now Q1, in Q1 when 0 is applied, it goes to Q2. So when 0 is applied, it goes to Q2. In Q1 when 1 is applied, it goes to QT now. So when 1 is applied, it goes to QT. In Q2 when 0 is applied, it goes to QT itself. And in Q2 when 1 is applied, it goes to Q2, Q3. And in QT, either when you apply 0 or 1, it always goes to QT itself. So 0, 1. And in Q2, Q3, when 0 is applied, it goes to Q2. And 1 is applied, and now we make a self loop here, it comes to itself. So when 1 is applied. Now this diagram is called as a DFA diagram. Perfectly, it is called as a DFA diagram. So thanks for watching the video.